Hey, Uchenna here. Welcome back to the channel. Today we're solving another Leetcode problem, and we're going to be solving problem number 56, merge intervals. So let's get to it. For this problem here, we're given an array of intervals where intervals I represents the starting time and the ending time of a specific interval. And the goal here is to merge all overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. Okay, so for example here, in the first example, they give us this list of intervals, of 4 intervals specifically, and the output results into 3 intervals due to the first 2 intervals being overlapping. As you can see here, we have an interval that starts from 1 to 3 and another interval that starts from 2 to 6. And you can think of these as meeting rooms. So um, essentially, this room will still be going on at the time that this room starts. So therefore, there's going to be an overlap in the time and the time frame. So with that analogy right there, you can kind of see how we're going to be going about solving this problem. We're basically going to be iterating through our intervals and seeing if the previous room is still going on while we try to access the current room. So for example, if we were to start from this interval here and we look at the interval previously, and that previous interval is still going on while this current interval is trying to start, then we know that there's an overlap here. So this is a nice question to understand how to use stacks in particular. And yeah, so let me get a little bit more in depth with the explanation here on the drawing board. So this is the first example here that's given on Leetcode. You can see these 4 intervals, and I draw a number line here to make it a little bit easier to visualize. And clearly you can see that this interval here is overlapping with this interval. So this first interval overlaps with the second interval. And the way we know this is that the previous interval's end is greater than the current interval start. So that's going to be very important to know. So if the prev end is greater than or equal to the current start, then we have an overlap, right? So since there's an overlap here, we need to merge these intervals in such a way that we don't have any more overlap. So how to do this is to make this interval in the range from 1 to 6. Why? Because that way we know that in the room of 1 to 6 we can have no overlap here. So the new interval is going to be one that spans from 1 to 6, and as a result these two previously intervals will be removed, and this will be our new interval. So let me go about explaining how the algorithm works here. So for this algorithm specifically, we're going to be using a stack, and the stack is going to be really helpful for us to maintain the order in which our intervals appear in regards to helping us check the previous interval and to look at the current interval, to compare it with the current interval rather. So the purpose of the stack here is what I just explained, and it's going to be initialized with the first interval here. So the first interval that we have in our input is what we're going to initialize the stack with. And with that being said, since we know that we have a value in our stack, we don't, when we iterate through our input, we don't have to start from the first interval. We can go ahead and start from the second interval. That way, we know we're always going to be comparing 2 different intervals together, right? So the intervals that we're going to be comparing are going to be the intervals that we're currently on in the specific iteration and the top of our stack, because the top of our stack is always guaranteed to have the last interval that is in the specific order that we're looking for. So as I said here, or as I just previously explained, we're going to compare this interval with the top of our stack, and we see that there's an overlap here because 3 is greater than or equal to 2, So we're gonna merge it, and after we merge it, we're just gonna pop from our stack, and now the new top of our stack is gonna be 1 to 6. And then we're gonna iterate again in our input over to 8 and 10, and repeat the same process, right? We're gonna compare 8 and 10 to the top of our stack, and we see that there's no overlap here because these can be described as being in distinct ranges. So we don't have to do any merges here. So we continue to iterate through our input. When we go to this index here, we see that 15 and 18, and 1 and 6 doesn't overlap as well. So we can simply just add that into our stack. And I forgot to do that in the previous step. So as you can see, when there's no overlap, we just have to add the current interval that we're on into our stack. So that's what I would do here. So as a result, this will be our output. 1, 6, 8, 10, 15, and 18. And this is what we're going to be returning to the solution here. And if you look at Leetcode here, that's what they have here. 1, 6, 8, 10, 15, and 18. Okay, so now this is the approach for the algorithm, but there's also one key thing that we have to note, and that is that we're not guaranteed to have a sorted input like this, right? This algorithm that I just explained works pretty well because the input is already sorted. You can see every single start time is sorted in ascending order. So if we go from here to here, we see that 1 to 8, 15 is all sorted in ascending order, but that's not a guarantee, right? Like the input can be given to us in such a way that 18 goes before 1 and 3 or something like that, and as a result, this algorithm wouldn't work. We'd have to change it up. So a simple thing that we need to do to just account for that is to just sort our input before we start to do anything here. That way we know that this algorithm is going to be constant and work across all different types of inputs. So let's get to the code and I'll explain what I'm doing as I'm coding. So as I just explained, we'd have to sort our input to account for that edge case here. And we need our stack to be initialized with the first interval in our intervals list. So you can look at the stack as being the result slash merged intervals. And when we do that, we can go ahead and start iterating through our intervals and doing the operations that I mentioned. So we iterate through our intervals. Starting from the second interval. And what we need to know is the previous end and the previous start, as well as the current end and the current start, in order to do that comparison. So to do that, we can say prev and prev start equals, or let me switch this over here to make it a little bit more legible. So the previous start and the previous end is going to equal to our stack, the top of our stack, and index 0, that'll be the index for the starting point, as it says here, and something similar for the ending point. So it's top of our stack, but index 1. Then I can say the current start and the current end is equal to the current interval that we're on and the respective indices. Okay, so now that we have these two start times and end times, we can do a comparison. So the check here was that if the previous end is greater than or equal to the current start, then there's an overlap. And when there's an overlap here, let us go back to the drawing board. What we had to do was we had to pop from our stack and then append a new interval here. So that's exactly what I'm going to be doing here in the code. So we create the new interval. Interval equals previous starts, and we want to get the maximum end value from the two intervals here. So for example, if this interval here, if our 1, 3 were to actually be something like 1, 7, it would make more sense for us to take the 7 as an ending value rather than the 3, or rather than the 6. So we can do that by simply using a method here, a function here, a max function, to get the maximum of the two ending values. Then we just pop from our stack and append to our stack the new interval. New interval. Otherwise, all we need to do is just append the current interval that we're on. And as a result, this should be the entire merged intervals. Our stack will hold that. So we just need to return our stack. And if I didn't do anything incorrectly, that should be the entire code. So let's run it. And this passes both test cases. Submit it. And this works. So let's talk about the time and space complexity here. So right away we can say that the time complexity is going to be n log n because we have to sort, and the for loop is going to be O of n, and n log n takes priority over O of n in regards to amortized time complexity. And the space complexity will be O of n because we're using an extra stack. And just to confirm with that, we have a nifty thing here in Leetcode. So time complexity O of n log n, space complexity is O of n. So that about sums it up for this video. And if you have any more questions regarding this problem I've just solved, make sure you leave a comment down below and I'll be quick to respond. Don't forget to hit the like button, the subscribe button, and have a good one.